Hello everyone, welcome back to Hands-on Study Hub. In today's video, we will be performing 16-bit addition of data stored in memory locations using the 8051 microcontroller. I will be explaining the logic and execute it step by step in Keil Microvision 5. The 8051 microcontroller is an 8-bit processor, meaning it can be handled only 8-bit data at a time. To perform 16-bit addition, we need to break the operation into two 8-bit additions. Initially, we need to add the LSBs and then next we need to add the MSBs along with any carry from the LSB. For better understanding, let's see this once. If the question is asked like this, like 16-bit addition between 4321H and 8765, then you need to perform 1256 LSBs and 3278 MSBs. Then first you need to add the LSB numbers and store the result in memory location 21H. What is our aim? We need to store the result in some memory location after performing the LSB addition. Okay, and then next we need to store the result in another memory location after performing the MSB addition. Okay, here 1, 2, 5, 6 are LSB bits and store the result in 21H. And then next 3, 4, 7, 8 are MSB and store the result in 22H. Here I consider the 21, 22 as you wish. You can consider some 30H, 45, 46, 78. Okay, depending upon your constraints, you can consider the memory location. Okay, for storing 1, 2, 3, 4, 5, 6, 7, 8, here I consider the 4 registers from register bank. R0, R1, R2, R3 are registers. Okay, in some questions, they will not specify any 1, 2, 3, 4, 5, 6, 7, 8. At that time, you can proceed a normal 16-bit addition by breaking them into two 8 bits. You can add 1, 2, 3, 4 and store the result in 21H, and then next you need to add 5, 6, 7, 8 and then you can store the result in 22H. Okay, for better understanding, let's get into the program. So this is the program. As we all know, the 1, 2 is loaded to R0 register, and then 4, 3 R1, 5, 6 R2, 7, 8 R3. Now we need to perform the 16-bit addition. For that, the R0 is loaded into accumulator, and then R0 is get added to R0 R2 register, which are the LSB bits, and then after adding the LSB we need to store the result in memory location. Here 21H is the memory location, and then next you need to add the MSB bits. So 43, 87 are MSB bits. For R1, R3 you need to get added and then store the final result in 22H. And then next program 1, 2, 3, 4, 5, 6, 7, 8 gets loaded into R0 register. Here in question they not specified any 1, 2, 3, 4, 5, 6, 7, 8. Here just I consider the numbers and I get added the R0, R1 and store the result in government registers. Or here instead of registers you can use some memory locations. For that, replace it as locations 21H and then your location 22H. Okay, after loading after adding R0, R1 and store the result in 21, and R2, R3 and store the result in 22. After storing the result, we need to check for execution, right? For that, let's see here. Whatever the result which gets added, it gets stored into the location 21 and 22. Here 10, 11, 12, 13, 14, 15, it can be written in hexa values like A, B, C, D, E, F. Okay, for program 2 you need to perform the program 2 and post your answer in comment section. Now let's start executing our program in Keil Microvision 5 software. For this, open Keil Microvision 5 software and then click on project and go for new Microvision project and save your program. it's a 16-bit memory location, 16-bit addition by using memory location, right? And save it in some path. Here I saved it in desktop and click on save, and then select your microcontroller device 𝐸-𝐸-𝐸-𝐸-𝐸-𝐸-𝐸-𝐸-𝐸-𝐸-𝐸-𝐸-𝐸-𝐸-𝐸-𝐸 and click on 𝐸-𝐸-𝐸-𝐸-𝐸-𝐸 and click on no, and then select file and click on file, and now start writing your program, which is 16-bit addition. For that, you need to first load the input data into registers. Move R0, hash 21H. I just copy this data for further 3 registers and enter. Now modify this as R1 and R2 and R3. It is 1 to right. It can be modified as 43. Next 65. Next 87. You need to move the data into accumulator and registers. For that, move A, R0. We need to load the R0 data into accumulator, and then next we need to perform the addition operation in between LSB bits, 21, 65 or LSB bits. For that, add A, here 65 is LSB, right? R2, and then next we need to store the result in 21H memory location. 21H, A. Next again move A, R1, and next we need to add the with A, R3. We need to store it in memory location 22H, A. Okay, R0, R2 or LSB bits, R0, R2 or LSB bits, R1, R3 MSB bits, R1, R3. Okay, done. And finally, you need to give the command call instruction and okay. And the next, you need to save it. It's like 16b add m.asm. ASM is the extension, and you need to save it and click on save. You can observe here the program file has been saved, and right click on target, options for target, and go for output, create a hex file and click on OK. And then next right click on source group, add existing file. You need to add your file. It's 16-bit 16b add m add .asm. Here we're not getting. I think 16 add. Let's once save it as again. Here we're not getting .asm file. For that, let's create one again new file. We're not getting. For that again you need to save it as and give. Okay, here we give 1b. Okay. You need to add it, right? Click on add existing file. 1b add .asm. You need to remember the .asm extension, which name you have to give in here. Try to remember which name you have been saved this file. Okay. you need to click on add and then okay. The program file has been added to source group. Next, after that you need to check for errors, zero errors, zero warnings, and then click on build in, click on rebuild. After that you need to go for debug session and click on start and stop debug session and click on OK. And then next you need to, before you start executing your program, we need to go for memory locations, because here we used the 21H and 22H are memory locations. For that you need to give the instruction like I:0 cross 20H. Now 20H. Okay. Now you start executing your program. Okay. You can observe here, after executing our program, our answer is CA86. Okay. This is the 21, this is the 20H, this is the 21H, this is the 22H memory location. Okay. 2165 gets answer is 86 and 4387 answer is CA. So that's it for today's tutorial on 16-bit addition by storing the resulting memory locations of 8051 microcontroller. Don't forget to like, share and subscribe to my channel Hands-on Study Hub for more practical microcontroller tutorials. Drop any questions in the comment. I will be happy to help you. Thank you.